Hi, so this is the last R lecture in the TA class, so congratulations for taking all the course from me, and I hope you have a good exam score in the final exam, so let's begin. And I think that uh, until the last lecture, until the previous lecture, we learned about two sample test, which uses some hypothesis test. And we usually use normal distribution or t distribution for constructing the confidence interval or doing the hypothesis testing about two sample or paired sample test. However, from now on, we are dealing with a chi-square test. So, which means that we are going to deal with a chi-square distribution, which was not dealt with previously. So I think it is not much familiar with you, but I think if you are already familiar with the previous topic about constructing confidence interval or doing hypothesis test as user, there will be no difficulty in understanding all the things. So let's begin. And I think that the most important thing is that uh, we use chi-square distribution when we are dealing with the categorical data. So I think you have to notice about this fact. And so when we are dealing with the categorical data, we usually make a continuous table to see the result of the table. And then based on the continuous table, we usually are able to do some hypothesis testing or construct some confidence interval. So yeah, I will skip the theoretical part because these are will be done. This will be done by the Professor Park, and we are going to deal with the two examples in this course in this lecture today. So the first is the ESMA data. So that yeah, here is the ESMA data basically. So I think I will assume that you already know about the what chi-square test is and what chi-square distribution is already. So I will delve into the example number 1 directly without any explanation. And I hope that you already know how to how to do hypothesis testing based on this example number 1. So the first thing is that we have to make the continuous table for this example number 1. So yeah, this is nothing but just explaining about the chi-square distribution. So as you already know about the some functions in R programming, which deals with some distribution, chi-square distribution also has 4 kinds of function, which is a p chi-square and q chi-square and r chi-square, and there will be also d chi-square. Yeah, here d chi-square. So as you already know, d chi-square gives us a density, and this gives us a pnom. The percentile and quantile, and the some random sample from the chi-square distribution. And as you already know, chi-square distribution only gets the hyperparameter as the degree of freedom, just one hyperparameter. And then let's go to the example number 1. And this is nothing but making a continuous table by using the matrix function here. So after putting the adequate value here, you can get the continuous table, which has the form of matrix. And then we are dealing with the data. So the next step is getting each summation of each row or each column. So this is nothing but just getting the sum of each row, or the sum of the summation of each column using the sum function, and store its value into our own variable. So yeah, after summing up all the values in the contingency table, we store it in our total variable. And then after running the code, you can see that the summation value has the same value with this total column or total row here. So all the counts of the ESMA data is 790, which is the same as the total variable. And then the next step is calculating the probability. So we can get each probability by dividing each total value by the real total. So we can get each probability by dividing each sum of row or sum of column by the total. So it is very easy. So you can also get each value, and then you can also see that each value, and then yeah, so because we are assuming that in null hypothesis, we assume that each category has no relationship with each other. So we assume the independency from each other categories. So in the null hypothesis, we can get each probability by just multiplying two probability without any generally. So this is why I multiply each probability when I want to get each probability in our own contingency table here. So after running this code, you can also see that these four values has the same value in here in this contingency table. So yeah, the first number is identified. The first number means the row, and the second number is a column. So that's it. And to make a expected frequency, we multiply each probability again with our total, the sum of all the values. So that we can get the real expected frequency. This is why I use this formula. And then if you check the value, each value, you can see that these four values are identical to these four values in this contingency table. So I'm just following each step to do a hypothesis testing that in each the null hypothesis that our category has asthma and smoking are independent. So I just follow all the steps in this hypothesis testing, and that we can make the values again in the matrix form by using this matrix function. So you can see that this matrix has the same form with this expected frequency contingency table under the null hypothesis. So this is our contingency table under the null hypothesis, and this is the contingency table that we just observed as a sample data. And then based on the null hypothesis, we can do a hypothesis testing by comparing these two contingency tables to each other. And as we know that this formula follows the chi-square distribution, we can get the p-value based on the null hypothesis, and that we can make a decision based on the result. So this is the whole procedure of doing the chi-square test in our sample. And the next part is nothing but calculating the statistic here. So after we get the difference between the two continuous table pointwisely, and then scale it and divide it by the each value in the continuous table that we calculated again. So this is and some order values. So actually there is here you can also refer to this formula. However, in the R programming, when we do the function by using the sum and scale and divide it by our own value, it helps us do this element wise. So you don't have to use the for loop, or you don't have to repeat the same procedure element by element. This function just gives us the whole value pointwisely, so you don't have to do that. You don't have to repeat the same thing many times. So you can see that when we get the difference from the two metrics, you also have the metrics as a result. And if we also use the other function like summation or the scale, you also so this inner input in the sum function has the matrix form with a 4 element, and sum function gives us the summation of all the values in the matrix. So it gives us a 215.565618, which is the same as this value. So with only this one code, only a one sentence code, we got our own test statistic, which is about 215. And we know that this test statistic follows the chi-square distribution with a degree of freedom, which is n1 minus 1 multiplied by n2 minus 1. And because we have n1, because we know that n1 is 2 and n2 is 2, our degree of freedom in this situation is 1, because it is nothing but 1 multiplied by 1. So this is the reason why we use the chi-square distribution with a degree of freedom as 1. And this is why we want to get the p-value by getting the probability when our test statistic, our chi-square distribution is greater than our own test statistic. And as you already know, this is same as the this can be derived by using the p chi-square function with a lower tail option as false. Here, degree of freedom is at 1, and this is our own test statistic, and lower tail option as false. Or we can also get the same value. So this is we can also get the same value by deducting the result from the chi-square distribution from 1, but you have to set the loyalty option as true. And in this case, we get this result, but this is the scientific notation. So if you want to get the numeric expression, you have to run this code. This code will help you read in the numeric notation. So after running this code, this option, and then p chi-square distribution again, and then you can see that it has very close to the 0, which is much less than the 0.05, which is the significance level our own, which is our own from our own test. So, which means that our p-value is much less than the our significance level, which means that we are able to reject the null hypothesis. That's it. So this is the summarization of our chi-square test. This is the example number 1. And I think it will be also helpful to know the chi-square test function. So if you want to know more knowledge about this function, you can run this code with a question mark, and then our programming will give you the description about the chi-square.test function. So I just want to explain that by doing this code, we could do the hypothesis testing based on the formula. However, there is also a function that helps us doing the same hypothesis testing. So we can also expect that this chi-square test function gives us the same result from the previous one. So you can see that as our input, the only input we have to use is just the original sample. So which is ex1 that we already made at the first time here. So this is just a sample in our example number 1, and the only thing we have to do is just putting the ex1 in this function. Then if you want to see each observed or expected or statistic or p-value, you can run each code here. And then so this matrix is nothing but the expected frequency that we calculated. And then sorry. So this is just the observation, right? Yeah, here. So I'm sorry, apologize. And the first code gives us the observation matrix, which is the original sample, and the second code, the expected column, gives us the expected frequency matrix that we calculated with a very complicated formula, and the statistic column gives us the chi-square statistic, which is 215, which is the same as the here value. You can see it here. And then it also gives us the p-value here. And this is the same as the p-value as we calculated. So we can say that even if we use the chi-square.test package function, it also gives us the same result from the previous one, where we used our own original formula when we do the hypothesis testing. So you can also utilize anything. And I think it will be very helpful for you to use both of the result, both of the method, because you can get guaranteed if you have the same result from each other. And then I think it is also very helpful for you because there is nothing to be confusing, which is confusing in this part. So I would recommend using this one. And I also recommend that you have to know all the formula or all the steps of the chi-square test for your examination or for your homework. Even though I'm not sure. I don't know about any information about the examination or homework, but yeah, that's it. And example number 2 is the same procedure, has the same procedure with the example number 1, but with different row, the number of the row or column. So example number 2 is much more complicated, has much more complicated sample, but the procedure is the same as the previous one. So all of the procedure is the same. So if you already are familiar with the previous example, if you can understand all the thing, there will be no difficulty at all in understanding the example number 2. But it is more burdensome actually because we have a more element in our sample. So we are dealing with a 3 by 4 matrix here with each value here. So all the procedure is the same. After getting the summation, and then after getting the probability here, and after getting each probability in the continuous table, total of 12 element here. And then you can also get, finally we can get the expected frequency of each element by multiplying the total value with each probability. And then you can also check each value here. So you can compare to each result in this lecture material. So there's no difference to each other. And as the final step, this is the expected frequency. So after making each element into also the matrix form, you can see that our expected frequency matrix has the same value as this continuous table here. So you can see that there's no difference from each other, which means that we successfully calculated all the things based on the R code or based on this class material. And then there's nothing different previously. So with only this one code, one sentence, we can get the test statistic, which follows the chi-square distribution with degree of freedom as 6, because we have 3 by 4 samples. Our degree of freedom is 3 minus 1 multiplied by 4 minus 1, which is 2 multiplied by 3, which is 6. So that this is the reason why we use the chi-square distribution with degree of freedom as 6. And for getting the p-value, we have to calculate the probability when the chi-square distribution is greater than or equal to our test statistic, which is very small. And it is the same as this code. You can see that this p-value is exactly the same as this p-value here. And as this value is much less than the 0.05, which is the significance level, in this time also we can reject the null hypothesis. Again, if we use the chi-square test function, you can also get the each observation or expected frequency or statistics or p-value as the same thing. So the statistic is here and p-value is here, and you can see that statistic and p-value and the contingency table and observation table are the same or the same with if you use this chi-square test function or if you follow all the procedure in this formula. So this is all about the chi-square test. So I think this is the end of the class, and yeah, have a good day. And I will end up this lecture by summarizing all the things in Korean briefly. So I hope that you have a good grade in your final examination and hope that you have a good luck. Thank you. 그래서 카이스퀘어 테스트는 이제 카테고리컬 데이터를 할 때 다루는데 한국말로 조금은 해야겠죠. 예를 들어서 이제 담배랑 천식이 관계가 있는지 없는지 궁금해요. 그럴 때 이제 누 하이포서시스를 관계가 없다 아니면 얼터티브 하이포서시스를 아니다 관계가 있다고 설정한 다음 관계가 없을 때를 기반으로 저희가 테스트 스태티스틱을 꼬일 수 있다는 거죠. 왜냐하면 관계가 없으면 이 멀티플리케이션 룰에 의해서 인디펜던트면 그냥 2개 곱하면 되는 거잖아요. 2개 확률을. 근데 관계가 없다 했으니까 누 하이포서시스에서 그냥 곱하면 되는 거죠. 어떤 걸 곱하냐면 처음에 이게 샘플이니까 그거에 따라서 서메이션을 구하고 그 다음 프로버빌리티를 구하고 그 다음 그냥 곱할 수 있죠. 독립이니까. 그 다음 또 이제 토탈 넘버를 또 곱해요. 그러면 이제 익스펙티드가 나오는 거죠. 여기서 그래서 이제 이게 나왔고 이거는 원래 샘플인데 저희는 이게 인디펜던트라고 설정을 하고 구한 게 오른쪽이죠. 왼쪽은 그냥 저희가 관찰한 거고. 그래서 이거 2개를 비교해 봤을 때 이게 정말 있을 법하지 않게 일어나는 거예요. 만약에 그걸 p 밸류를 통해 구할 수 있죠. 근데 p 밸류를 어떻게 구할 수 있냐면 저희가 분포를 알아야 되죠. 근데 이미 이렇게 스태티스틱을 저희가 만약에 구할 수 있다면 이 2개의 차이를 뭐 제곱해서 오른쪽 거 밸류를 나눠서 뭐 다 서메이션을 한 걸 만약에 구할 수 있다면 심지어 구할 수 있죠. 되게 간단하게. 그게 이 카이스퀘어 디스트리뷰션에 따른다는 게 알려져 있어요. 그러니까 구해서 이게 나왔는데 이게 카이스퀘어 자유도 1인 카이스퀘어에 따르니까 이제야 드디어 p-밸류를 구할 수 있는 거죠. 당연히 구했더니 뭐 당연히는 아니지만 구해봤더니 엄청 작게 나왔고 0.05보다 작으니까 원래 독립이었다는 가정을 위잭할 수 있다. 이렇게 되는 겁니다. 그게 바로 이미 알고 계시겠지만 하이포서스 테스트의 당연한 흐름이죠. 그래서 이게 총 설명이고요. 2번째 example은 사실 간단한데 귀찮다는 거죠. 똑같은데 앞에는 2x2였다면 지금은 3x4니까 뭐 나중에 자유도가 6인 거 말고는 크게 달라지는 게 없습니다. 그렇게 구하시면 되고 한 학기 동안 정말 고생 많으셨고 네, 이만 마치겠습니다. 감사합니다.